And this recording will be available at the end. We'll go ahead and post it to the website. Just make sure that recording happened. Okay, it is in fact doing it. Whoops. Okay, great. You can see the talk. All right, so hi everybody. For those of you I don't know, my name is Dr. Vidushi Bhattacharya. I'm a former NASA scientist turned astropreneur. Space entrepreneur is really my passion and interest, and I'm really excited to provide this particular webinar for you guys. I see in the list, as I said, we have about 118 people who are on. About half of you, I already know you're from the sector or from related sectors, and I'm really excited about the fact that more than half of you are actually from other fields. I did give a lecture in space law last week. I know we've got a bunch of newcomers from that particular conference, and I'm seeing a bunch of other people here too from a lot of different areas. So, okay, I'm here. Somebody has a lot of background noise. Let's see, is everybody muted? I have muted everybody. Okay, if you are not muted, please go ahead and do so. So usually when I give these classes, I get up on stage or I get up in the front of the classroom and I ask people the same question that I'm going to ask you, which is how many people here wanted to be an astronaut when they were a kid? And in general, we can make eye contact with the audience and you can sort of get a sense of where they're at and just let the knowledge transfer begin. But in this case, we are in a situation where I can see some of you as tiny little boxes, and we're just not getting the same kind of contact that we normally would. And that's actually part of the motivation for this particular workshop, is just to look at how we're going to cope during the pandemic and afterwards. So let me go ahead and start this poll for you guys. Here's your first poll question. If you had the opportunity, would you want to travel to outer space? Now this should come up on your screen. Go ahead and click on your answer and hit submit. I see somebody saying he still wants to be an astronaut. Okay, I don't see that it's working. Is this not working? All right, so let's give this another 15 seconds or so, and then I should be able to give you the results of the poll. Right, so I'm going to share the results with you. Now tell me what you see, because I'm actually seeing 0% here. Can you buy the space ticket now? Yes, of course. Do you guys see the numbers?
91% say yes.
Okay, awesome. Thank you, David. How are you?
Good, thank you.
Good. All right, so 91% say yes. Has anybody say already been there, done that? 11% say no, and 0% say yes. Thanks, Gokbang. This is interesting because I did actually send this out, as I do for many of my events, to my astronaut friends, and there were a couple on the mailing list, but I guess they're too busy. They did not show up. Right, so that's pretty cool. This tells me that a lot of us have been passionate about space for a long time. I'm going to try the next poll and see what happens with that, but until then, I'm just going to keep going with this, and I may have to ask you guys for feedback, so sorry about that. All right, so why should you guys be interested in outer space? The fact of the matter is you are already dependent on space technology. The best example of this is your mobile phone, right? We rely on our phones for everything from generating our grocery list to communicating with our families and friends to getting our news. And also we depend heavily on location services, which require satellites from space to actually figure out where we are. The signals from the satellite is received by our phone, and that helps us to understand where we are. So location services are key, and without satellites, we wouldn't be able to use half of the apps we have on our phone. So we're pinging space thousands of times a day. So there's a really cool reason that you actually want to be looking at the planet from outer space. Outer space offers a unique vantage point so you can see large swaths of the Earth at a time. Rather than getting hundreds of meters, you can get hundreds of thousands of square kilometers in one particular fell swoop. And this is particularly important for natural disasters, hurricanes and fires, for example. Another really cool thing about outer space is that it's full of abundant resources. Any of you who may remember your basic astronomy know that the early solar system was formed and asteroids broke off and they contain minerals from the early solar system. Now, those minerals are lying within those rocks in space, and they're very easy to extract. You don't have to go in and use mineral processes like you do here on Earth. No mining, no chemicals required. You can actually just go and pick those up. And parenthetically, we know how big they are. We know what they're made of. And some of those asteroids are worth trillions of dollars if you were able to get that material and bring it back. Anything from carbon to rare minerals like bismuth. Microgravity is also really interesting because when you're outside the pull of the Earth's gravity, you can do some very interesting biological things. You can look at pharmaceutical development, and there are also some pretty innovative manufacturing opportunities. The International Space Station is actually a platform of research, and they're already doing 3D printing up there. They're testing out microgravity on plants, on fish, combustion. There's a whole world of opportunity for anybody who wants to get involved. And as a matter of fact, we have some of our own students who run experiments on the International Space Station. So part of the reason I wanted to really start doing this online was I was looking around at what's going on globally with the economy. And we're talking about a post-COVID global economy that's going to be very different. We're going to need to figure out food security and supply chains. And this is where space is a perfect way to get involved, because we can use those large swaths of visualization of the Earth to provide large-scale data. So let me tell you quickly about myself. I have a PhD in space physics from UCLA. I started working back in the late 1980s on the Hubble Space Telescope, my first job out of college. And I've worked on spacecraft calibration, mission planning, done a lot of public speaking, and I also work as a media consultant. You can see here down below, there's a live commentary I did for the Indian Space Agency as they had the moon mission, the lander that attempted to land last year. And I've spoken at everything from TEDx to various forums all over the world. My favorite mission I've ever worked on is the Hubble, because that was actually my very first mission. Also met my husband there. And I've also worked on the Mars rover and a European Space Agency mission called Herschel, as well as a number of other missions. And I'm currently CEO and founder of Astropreneurship Hub. So this is a vintage picture. I just dug this up a while ago. This was taken on the Johns Hopkins University campus at the Space Telescope Science Institute back in 1990, just a few weeks before the Hubble launched. So let me get my mouse over here. I'll show you where I am right here. You can see one of the few brown faces in the crowd. And then here, this guy here in the tan suit, this is Riccardo Giacconi. He went on to win the Nobel Prize in 2002. So this was a group of about 400 engineers and scientists who worked on calibration, particularly on the software side for the Hubble Space Telescope. So a little bit about us. Astropreneurs Hub is really dedicated to the democratization of space technology and services. We started out in Singapore in 2016, and we now have offices in the US as well. We've had hundreds of global customers. And what we basically do is provide space-related training and education to a variety of people at different stages of life. Our team has a combined experience of 45 years in small satellite development, spacecraft operations, and astrophysics. So our team really is the real deal. We all have actual experience in the sector. Now, why are we interested in democratizing space? Well, space is now in a time where we're going from just technical development to actual ecosystem building. And when you're going to build an ecosystem, you need more than just space nerds like myself. You actually need people with background and skills in a number of areas so that you can actually build a full-on space economy. And what we find is people may be interested in space. 91% of you guys said you wanted to be astronauts. But when I ask, what would you do in space? You may say, I just have no idea what's going on. And it's sort of, there's like this black box, there's like this barrier to entry to the space sector. And so my goal today, if I do this properly, is to take away that barrier for you so that when you go offline after this, you think about it, you talk to your friends and your family about opportunities in space technology. Okay, did I get? All right, so these are some pictures of some activity that we actually do. This here is at the Art Science Museum in Singapore. We have given hands-on workshops with these handheld satellites called CubeSats. I can show you one of those in a minute. This is me and our CTO, Li Wei. We were in Adelaide at the International Space University where we gave a workshop as well. And we're also interested in working with people who just want to ideate and think about space. So I am the national coordinator for the NASA Space Apps Challenge in Singapore, and this was last year's event. And one thing I should just tell you is Singapore is a small country of 5.5 million people, but we actually have had a team from Singapore be one of the global winners. There's 6 teams they pick each year that have the best idea for an application of space data. And a couple years ago, we had a team from Singapore be one of those 6, which I think is pretty remarkable. So a little bit more about these workshops. They actually require the use of a satellite that you plug into your own laptop. And the reason we do it that way is we really want you to get comfortable with technology, and we want you to get a feel for how hardware and software work together. And then we also launch experiments to the International Space Station. So we've launched 7 student experiments to date. And we're hoping that in the next year we launch a couple more. Now, with regard to the CubeSat workshops, I know some of you are asking about those. The issue now is we can't meet face-to-face, right? And so we're gonna have to do something via Zoom, and I think this is the best way to just keep going with our Astropreneurship workshop so that we can continue to build the ecosystem before we can all get together and work on hardware. So we've had more than 300 customers in our different workshops so far, and including this group, if everybody shows up, that number is going to actually increase quickly to about 400. So you've all signed up, and I appreciate your time. And let me just give you a sense of why I think you guys should be here. What are the learning objectives? What do I hope to offer you? I hope that by the end of this presentation, you understand the difference between big space and new space. I hope you understand why new space needs you. New space is the commercial space sector. It's new because the technology is faster and it's much less expensive, and it is very different from what we traditionally used to do. So what I'd like to do as we go through this is learn about potential space-related growth markets in the post-COVID-19 global economy. And I would like you to be able to identify online resources that enable you to study further about new space companies. And here's the real thing, the bottom line. I don't want anybody after this to think rocket science is mysterious or rocket science is hard. That term in and of itself is very loaded. And I want you to walk away from this feeling, rocket science, yeah, I get that, or yeah, I know where to look if I want more information. So let's talk about big space for a second. These missions from NASA, for example, the Hubble Space Telescope, that was a $4 billion mission, right? $4 billion. And the Galileo spacecraft, this is one of my favorite missions. This one, I use the data from this to do my PhD on Jupiter. This one is, again, a multi-billion-dollar mission. Now, these missions took so long to build that people would actually retire before they actually saw their spacecraft go up. So they were long timelines, huge budgets, but that was the way not just NASA, the European Space Agency, the Japanese, the Indians, everybody used to do it that way. We're now, though, in a realm where technology has really evolved. So if you think about this computer that you see on the left, this is what's called a Sun workstation. And this thing weighed, I'd say a good 20 kilos, 40 some pounds. And it was huge and sat on your desk. I worked with one of these in the Hubble Space Telescope computer lab. They were so expensive, they were about $54,000 in today's money, that we actually had a cyber lock on the computer room so that only selected people could go in there. This was in the 1990s, $54,000. And so today you've got your phone, which is maybe $800. The phone is 150 times faster. It has 200 times more memory, and remember how heavy I said 20 kilograms for the big old computer? This thing is 100 times lighter. I mean, sometimes I even forget that I have it in my back pocket. It's so light. So if you think about the evolution of technology, we know that the phone is a tiny and amazing computer. And then I was telling you about our Cube satellite workshops. This is actually one of our handheld Cube satellites. This is a desktop model. This is not one that would fly, but it basically has the same components. It's a 10 by 10 by 10 centimeter cube. It's an industry standard. It should weigh on the order of 1 kilogram. And actually on the outside, you would put some solar panels to give it some power. And these things fly independently in space. And you can build and launch one of these for on the order of $300,000. And some of these have cameras that are good enough to take pictures that are better than what 20-year-old government satellites would actually do. So 4 billion versus 300,000, similar kind of capabilities. And you can launch one of these in the course of just a few months rather than waiting years and years and years. And one of the real advantages to being able to swap out technology that quickly is if you think about your cell phone camera and how good it is today, and you think about the camera you had like 2 years ago, the instruments are progressing very quickly, and it's really nice to be able to put the latest and greatest electronics on a satellite, such as one of these CubeSats, so you don't have to wait around for years and years and years to incorporate the latest technology into what you're sending up to outer space. So here we are with the CubeSats, and all the innovations that we have over the past few decades have enabled us to be here. This here is a very exciting event that's kept coming up. I put this picture up in particular because the astronauts are about to go into quarantine. On the 27th of May, in just a few weeks here, SpaceX is going to be the first commercial company ever to send humans to space, to the International Space Station. And this is huge because we have had no way to get Americans to space, for instance, since the space shuttle program ended. The Russians have been ride sharing and giving astronauts from the world over rides up to the space station. Well, you can send supplies through the Americans, for example. There has been no way to send humans up until very recently. Now, if you're wondering why these astronauts are going into quarantine, they have to make sure that they themselves are germ-free and healthy before they go up to meet the rest of the astronauts that are up there, because anything that they have in a closed environment like that, they would be very contagious, and they would end up giving it to somebody who's in space right now, and there'd be no way for that person to come back down for weeks or months on end. So what are the benefits of space technology? We're talking about spending billions, or we're talking about spending hundreds of thousands of dollars. And why bother? It's cool, yes. It inspires people, yes. But there are some incredible technologies that we use here on planet Earth on a daily basis that wouldn't have been invented if it weren't for the need, for the drive to work on technology for space. This is the Herschel Space Observatory. It's the European Space Agency telescope. I mentioned I worked on it earlier. The golden material you see here, this yellowish gold material, that is actually a mylar blanket. These were originally designed to moderate temperature fluctuations on the instrumentation and on spacecraft themselves. So scientists and engineers invented these, and what's really interesting is over the years, people have found uses for this material here on Earth. This here is a mylar blanket like you might find in a first aid kit. It costs $1.69. And you can go onto Amazon and you can just order these online. And if you've ever actually had one of these, you know they're incredibly lightweight. They feel like they're nothing, but they're just very, very warm. So they are standard in many first aid kits today. And the transition, I should add, between space use and Earth use was not done by a scientist or an engineer working for the European Space Agency or NASA. That's where people like you came in. People who were thinking out of the box and were looking at space technology and figuring out a way to make it accessible and useful to people on planet Earth as a whole. So why don't we talk about what's happened last year in space? 2019 was a very exciting year. And what I've done here is I've divided the different major projects up into commercial and government projects. So on the commercial side, SpaceX did do a demonstration of their Dragon capsule, the one that's going up on the 27th. They were actually able to send it into space and make sure that everything worked last year so that they can use it this year. LightSail 2 is a commercial product. It's a solar sail. It's a very lightweight CubeSat, another one of these small sats that has extended solar panels that actually use pressure from the sun to sail. So you don't need to have your own engine or propulsion system on board. You can use solar pressure. This is the second time they launched a CubeSat then that actually unfurled its solar panels and it worked, which is very cool. SpaceX has been working on another rocket called the Starhopper and also their Starship. And SpaceX has launched their Starlink constellations. Now, these are a set of tens of thousands of satellites that are going to provide internet from space to all parts of the Earth. And then Virgin Galactic also flew a test passenger, and they also went public. So they are a publicly traded space company now. On the government side, there were some pretty cool things. China landed on the far side of the moon, not an easy feat. On the International Space Station, there was an international team of women only doing a spacewalk. Now, for somebody who grew up knowing about the Apollo era where it was only dudes, for me particularly, especially as somebody who has 2 daughters, I find this to be really exciting and inspirational for the younger generation. They also had a female astronaut begin a year-long mission in space. And this isn't just because everybody's interested in equal rights for men and women. That's a great concept. I totally endorse that. The thing is, astronauts serve as biological labs. Their physiology, their heart rates, their blood, their physical systems are monitored constantly. And when we are looking at medication for males versus females, there are physiological differences that need to be understood. And if you're monitoring somebody like that 24 hours up there, it's really important that we get a full set of data for all of humanity, not just for 50% of it. So what else? Let's see. The Chandrayaan-2 moon crash. I showed you that live interview that I did for the BBC on that one. That's probably one of the most awkward moments I've ever had on camera. The trajectory was pretty clear from the map they were showing on the screen. It was actually coming down and then just crashed, right? You could see the line that showed the altitude just crash, and the reporter's asking me in a very posh accent, "What do you think's going on here? Somebody's whispering into the ear of Prime Minister Modi." And, I knew what had happened, but it was, just wait and see and wait and see. Now, India also last year decided to destroy a satellite. They're not the only country that did this. The US has done it, China has done it, and Russia has also done it. These are satellites that belong to the country that no longer work, that they try to destroy as a proof of missile technology. And this brings up some interesting legal issues, which we can discuss later. The question here is, if you want a satellite, can you do whatever you want with it? And the answer is obviously no, because when you do shoot a satellite, it's going to break up into thousands of tiny pieces traveling at like 20,000 kilometers per hour, right? And that becomes everybody else's problem if they get hit. So regarding the moon, last year, Israel also sent a lander to the moon that didn't have much luck. That crashed as well. And then last year was the 50th anniversary of the Apollo 11 landing on the moon, and NASA announced that it's going to aim for the moon again in 2024, which is in just 4 years. So let's talk about this year, what's happened and what's actually going to happen. Again, I've divided this for you into commercial and into government. And this is the mission we've already talked about, the SpaceX Dragon, first commercial crew transport to space. In late May, Virgin Atlantic is going to launch Launcher 1. It's going to be the first orbital flight of their system. And what they actually do is they have a plane, a Boeing airplane, on the belly of which sits their rocket. And they go up on the plane, and then the rocket releases, ignites, and takes off into space. It's a pretty out-of-the-box way to do it, and it looks really cool. You should go check out the YouTube videos on it. In late May, Rocket Lab's Don't Stop Me Now mission will launch satellites for the US military, for NASA, and American and Australian universities. That's another commercial interest. And throughout 2020, SpaceX will continue to launch its Starlink satellites. These are the Internet from Space satellites. The plan is for them to launch 120 of those this year. Now, they have taken out, they put in a request for launch licenses from the US FCC, and they've requested something like 30,000 launch licenses. So think about that, 30,000 satellites. That's a huge, huge number. And the idea here is to provide global coverage everywhere. On the government side, this is very cool. The United Arab Emirates is going to be sending up the Hope spacecraft. It's their first ever mission to Mars. They haven't even gone to the moon yet. They're just aiming big and going directly for the red planet. That's going to be launched in July. And then NASA is launching Mars 2020. And this particular mission will go put a rover on the surface of the moon and see if it can manufacture oxygen. You might be wondering why there are 2 July dates here. The Earth and Mars align very nicely every 2 years or so. So whenever that window comes up, everybody who's even close to getting ready aims to be ready so that they can go ahead and launch and meet up with Mars with the minimum flight distance that is required. And so regarding the moon, again, in late 2020, China is going to be launching the Chang'e 5, which will be a lunar sample return mission. This is not their first. I think it's going to be their second lunar sample return mission. So now let's talk for a minute about disruptive innovation. So back in the 1800s, everybody got around by horse and buggy. That was what you did. There was a global economy behind breeding, caring for the horses, building carriages, making sure that services such as food and lodging were available every 1 day's worth of travel for a horse, which was, I don't know, maybe like a few tens of kilometers. But then all of a sudden, we ended up with the Model T automobile. First, when the Model T came out, there was a lot of resistance, because if you think about it, the car was noisy, it emitted a lot of gas, and the horses were terrified. So it was very inconvenient to have these cars sort of running at the same time as the horse and carriage. But since then we've made a lot of progress, and now we actually have electric cars thanks to Tesla. But these are becoming very particularly popular, especially in California. And the innovations that we've had in the past 50 years actually have allowed amazing things to happen. So SpaceX's Falcon 9 goes up regularly. They've actually taken our student experiments to space, like I told you earlier. So they will fly up student payloads and commercial payloads and supplies to the astronauts. And they actually lock on to the International Space Station here, and they deliver goods. And the astronauts will take the goods and they will run the experiments for you. And then, of course, they will run experiments for universities and companies as well. So I want to just think about where we're actually going with all of this. Experiments on the space station, student outreach, all of that is really good. But here we are. We are now in a completely different mindset, a completely different realm. We've got this global pandemic. We've got this virus. So we have amazing issues just all around the world. I don't know how many of you have actually had to wait in line to be able to get into a store, but people on a regular basis are actually having to stand in line, whether it's in the rain or weather, wearing masks to be able to meet their basic physical needs, the needs for them and their families, just waiting for food. We have a significant issue with global food security. It's an issue that's related to supply chain, and it's also at this point starting to be related to the supply itself. So what does that mean? Are we still going to need the space sector after all of this? Are we still going to need the rockets? And are we still going to need to send people and stuff up to space? I'm going to say the answer to that is most definitely yes. These images here on your left, the first three, are taken by a company called Planet Labs, or they call themselves Planet these days. And they use handheld satellites. They use small satellites that are about 3 times longer than the satellite that I was holding in my hand a few slides ago. And they can take images of every point on the Earth every day. And why would you want to do that? We mentioned food security. So when you talk about food security, you can look down at a large swath of land and you can understand if crops are ready. You can understand if the crops are healthy. And if you want to contain disease spread, this is a very good way to be able to do that, looking at images. You can also look at crop yields, which are very important for the commodities markets. And with regard to getting the food from farm to table, as they say, timely transportation is really important. The majority of farmers in our world are small farmers, and they don't have the means to directly get their crops to the local nearest city. They have to rely on trucks. They have to rely on other people to be able to get them the means to transport their goods. And satellite data can be really helpful for this because they can accurately time when their crops will be ready based on the data that they're getting from space. And they can also actually just track where the supply trucks are, particularly in rural areas, so that they can be ready when the trucks do come to pick up their crops. And this is also important for the retail supply chain because getting from the nearest town to wherever the food is, as we know, it's getting harder and harder to do that with the shortages that we're finding around the world. So what else can you do from space? Natural disasters are ongoing. You know, we've got climate change, we've got people burning forests. It's really important to be able to figure out where fires start. And with regard to, you know, things like earthquakes, if you take images from space, you can figure out if there are roads that have been completely blocked off. And as a matter of fact, in 2015, this company Planet took images of some remote areas in Nepal where they identified villages that had completely been cut off. And of course, they had no internet, they had no way to get out of there. And helicopters were able to rush in and provide emergency supplies for those people until the roads were cleared. You can also monitor construction from space. Now, why is this interesting? You can identify encroachments so that you can look and see where land is owned by somebody versus where it's being actually developed by somebody else. And you can also address ecological and environmental threats. If you look at somebody who's mining and they're pumping dirty water into the ground, it's pretty easy to be able to spot that from up above. Now, all of these technologies will be usable by the average consumer once we have a full-on space-based internet system. And this is where the SpaceX Starlink system that I was talking about comes up. This will provide more than 30,000 satellites. I think it's upwards of 40,000 if you include other companies that will provide internet to everybody's phone from space. So let's talk about space technology and pharmaceuticals, particularly as we've been talking a lot, you've been reading a lot in the news about vaccines and about medications to help treat patients who've got COVID-19. When you're outside the pull of Earth's gravity, there's some interesting physical phenomena that happen that can really be taken advantage of when you're looking at space tech. And this is where those of you who have a biological interest or a medical background might want to come in and think about this. Right here, we've got some crystals. These are protein crystals that are formed. On the left here, you see this hodgepodge of crystal that has formed. And then here, you actually see, you see crystals in space, and they're much bigger, and they're much more durable, and they just look much cleaner, much more organized system. So a company called BioServe has been validating the structural integrity and the composition of these crystals on the International Space Station. And our students, as a matter of fact, have sent crystals to space. They did so in the year 2015, one of our clients. The other advantage to being outside the pull of Earth's gravity is there is some rapid testing that you can do, testing that would take a lot longer here on Earth. There's a company called Amgen that has a drug called Prolia. If any of you have family members who are elderly, they may be experiencing bone loss. Actually, astronauts in space also have a similar issue with bone loss. So what Amgen actually did was they sent some mice into outer space, injected with the drug, and compared those mice to those that were here on the ground. And the idea was that the mice who had been given the drugs would lose less bone loss than those that hadn't been given it. And in fact, their trial was ended very quickly in just a few months. And these guys with this medication earned something on the order of $3 billion in sales per year now. So bacteria growth, we don't really understand why, but bacteria grow much more quickly in space. And this is significant because they're particularly virulent strains of E. coli that affect people in a very big way. And they're not that common here on Earth, but if they get into space, they just really take off. And again, our students have been able to look at bacteria growth in space. This is a tooth of a 13-year-old kid's brother who was 8 in Australia who lost his tooth, and he lost 2 teeth. They put one on the International Space Station and kept the other one in the classroom to monitor bacterial growth in both of them. So let's change gears for a second now and start talking about all the innovations that are now out there that are, we've got cheaper technology, we've got miniaturized technology, we've got consumer needs that are coming about. when you look at the global commercial space economy, the global new space economy, today, I just did a check a little while ago, there are 1,780 startups around the world. This data is courtesy of a startup called New Space Hub. You can go to newspacehub.co if you want more information. These guys are a fantastic discovery platform for the industry. You can filter data. Let's just say you're interested, who's building a rocket in my country? Or who is really good at providing parts for cameras. You can go in and do filters and look at all kinds of components and systems that are being built. And I just pulled a few examples here. We've got everything from 3D printing, additive manufacturing, to agriculture, augmented reality, all the way down to medicine, propulsion, space tourism, and weather. So if you want to go to New Space Hub, I think this is really a good resource for you guys if you want to dig a little bit deeper. You can go to their website and then just put in this code here. Actually, let me go back to that. I'm going to type this into the chat box real quick for you so that you can go in and do this yourself. Hang on. Invite equal. All right. So if you go in, oh, you know what? I think I just sent that privately. Let me send that to all of you. Hold on. Copy and paste. All right, there you go. Yeah, if you go and sign up, you can sign up for free and just do some digging around, and you can get a nice 15% discount if you want to keep going and use their pro package. Right, so I want to run a poll here. Let me get this poll up here. Give me 1 second. Okay, it looks like that other poll is not going to come up here. Sorry about this. I don't know what's going on. But the poll was going to ask you something, which you can just type into the chat window. I was just asking where people are from. Right. Just to get a sense. I know some people said that we got people from Melbourne, from Singapore, Canada, Singapore, New Zealand, awesome. India, Italian living in Singapore. All right, so we've got lots of good answers coming through here. Chile. So Mars, all right, thank you, Mars Pathfinder. Yeah. So just to give you a sense of where some of these companies actually are and what they do, I picked a few representatives, just 6 of these here. In Africa, in South Africa, there are 12 space companies, and one of them is called CubeSpace, and they do components for CubeSats. In Singapore, we have 13 companies. Spectral does quantum communication, and they actually have launched some spacecraft already. In Australia, there's a company called MyRiota that similarly works on satellites. And in Australia, at this moment, there are 15 space startups. And in the bulk of space startups are in Europe and North America at the moment. So let me just pick a couple. I'm picking Indurosat here. Bulgaria has a couple different companies that work on CubeSats, and Indurosat is one of them. They've actually sent up their own CubeSats. And in North America, in Mexico, we have 4 companies that work in the space sector. One of them is ThumbSat, and they do educational and smaller satellite desktop components to promote educational learning in the space industry. And then in Brazil, there are 5 space startups, one of whom is AgroSatellite. And as you might imagine from the name, they look at agriculture, space-related data. So anytime you talk about startups, you have to talk about investments. Now, urgent economic needs will lead to more space investments, in my opinion. A lot of people say, well, space is a huge use of money, the sector might dry up. If you follow the sector, if you just go read any of these opinion pieces, you'll find people are being somewhat skeptical. But I really do think, and this is part of the reason I'm having this webinar, is that there's going to be a demand for the unique services that you can get from space. Now, so far this year, we've had $5.4 billion in investment. This is from a group called the Space Angels. They're now called Space Capital. They put out quarterly reports. I'm going to put their link in here too, spacecapital.com. mind this is autocorrecting for me. Send that out to everybody. They have some really handy reports, and you can break down the kind of investments at different levels, and you can look at the kind of sectors that they're going. Like they mostly spend on rockets, and the bulk of this money, you know, is SpaceX anyway, right? So it is rockets. But when you look at the beginning of the space industry to today, there's been a total of about $110 billion in private funding and commercial money that has been invested. If you'd like to read reports, there's another one here by Merrill Lynch and Bank of America. This one is a little bit longer. I'll cut and paste it for you guys later. So Merrill Lynch has done a study of where the space sector will be in 20 years. And they predict a $3 trillion space economy by 2040. Now that's equivalent to the entire economy of the country of England. So that's pretty huge. I see somebody's asking, if you have any more questions, I see somebody's asking about China. Go ahead and save these questions for later, and we'll have a Q&A at the end, and we can actually go through some of these. So, okay, $3 trillion, how are we gonna get there? What is actually gonna have to happen? Right now, we work on primarily in proof of concept of technology with a little bit of work going on in commercialization. But where's the workforce? You can't just have people working in STEM who are in the space sector. If we're going to build a full-on ecosystem, we have to go beyond business and marketing and media. We're going to have to need legal, finance, medicine, social services, and engineers and space-related people as well. So people in all of these sectors are going to have to come in and join the people who are already in the space sector. And that's part of why we provide the training to you guys, so that if you have a background in business or you know something about legal, then you might want to think about getting into the space sector. Oops, let me go back. All right, just to give you some quick examples. This slide is a bit dense. As I said, this is being recorded, so you will be able to get it later. So if you're in business and marketing, we need you first to look at sector growth and customer acquisition. If you're in media communications, we need you to help us with consumer buy-in. And space is an easy sell, right? It's very easy to tap into people's natural inspiration. We need you guys to help us do that. Legal, we need definition of property rights. The UN has cooperative treaties here on Earth. Somebody's going to have to figure out how to do that up in space. We talked earlier about the explosion of that one satellite that blew up. It's basically what they, as they say, the Wild West out there. You can do what you want without really having any enforcement. They have general agreements that people have. The United Nations has an outer space office, and people sign on to these treaties, but that doesn't mean that there's any way that you can enforce them. So somebody's going to have to figure this out as we become more of an off-planet species. Medicine and biological sciences, we already talked about that, pharmaceuticals, and also space tourism is up and coming. This is one of the things that they're working on in Blue Origin, for example, Jeff Bezos' company. And they're also talking at Virgin about sending tourists up into space. Social services, this is where we really need people to apply space technology for the greater good. You remember that space blanket I showed you earlier with the first aid kit? That's a marvelous example of something that was developed for space that's now in common use here on planet Earth. And in engineering, we need to look at tech transfer, biotech, chemistry, any of the other sciences or technologies can be applied to space. So we don't have to invent everything from scratch ourselves. We can go ahead and pick up what other people have done. And of course, we still also need people to continue to push boundaries who are in the space sector itself. And this is where we really do want to emphasize that everybody can come in. You don't have to have a PhD in space physics. You can come in with any of these other backgrounds, and you probably will understand the business side far better than the science nerds already do. So I'm just talking about the future of work and training and education. Let me tell you a little bit about what our workshops entail. You can go to this website, astrohub.co/workshops, ASTRO. Now, the workshops that we have are 90 minutes, and I don't believe in content dumping. We're doing this today just as a one-off so that you can get your feet wet. But I myself find it very exhausting just to be sitting there in Zoom watching somebody else put up slide after slide, because I could just have looked at that myself at some other time. What we do is we interact and actively engage with people just to make sure that you can come on board and get something out of this. So what we talk about in this particular online workshop is the status of new space. You'll get kind of a flavor of what we did today. You'll get a little bit more in depth of that. And then we take selected space companies and we provide you with an overview of those companies. We'll do new companies in each session, and then in-depth case studies and breakout sessions. So let's just say we're going to limit these to 20 people per course. So the 20 of you would break up into 4 or 5 groups, and you would be assigned a company and would give you some background information on the company. And then you'd want to go in and look at it and come up with an assessment and report back to the full group. And then what we want to do is take your findings and place them online on our website so that they become a resource for the greater space community. Now, of course, if you're open to it, we'll put your name on it, otherwise we'll leave it off. But there will be a series of reports, a repository of assessments from people from all kinds of backgrounds of particular companies in the space sector. Now, we're kind of doing this in a way to provide a similar kind of approach to what the Harvard Business School does with its case studies. If you're familiar with these, they'll do an in-depth look at a particular company and look at its history and what happened, and then have you decide what should have happened or was it a good decision or not. I have a forthcoming article on a space startup in the Harvard Business School case study series, so stay tuned for that. Now, what kind of companies do we look at? We've looked at some pretty cool images from Planet already, so let's go ahead and use them as an example. So what we would do in the workshop is we would get you a bit more background information on this company, Planet. We can tell you they are basically a company that provides satellite imagery of Earth. Founded in 2010, they've received more than 300 million in funding so far. They've got about 430 employees around the world. And I noticed that some of their employees were actually registered for this, so shout out to you guys if you're there. They have a fleet of about 150 satellites in orbit right now. So some of the questions we might ask you would be, how is their business model and technology, how are their business model and technology unique? How do you think this model fits into the current and the future consumer space markets? And this is where we're going to come up with very different answers doing this now versus what we would have done 6 months ago, right? We've got a whole different economy, a whole different series of challenges that humanity as a whole is facing. So I'll give you a little hint here. High cadence data is key to managing human systems. Not going to tell you more than that. You'll have to attend one of the workshops to find out. So how can you get involved? The first thing I would say is do take our webinars. Today's webinar is being recorded. As soon as it's processed, we're going to post it online for you. Please feel free to share that with anybody who's interested in the sector and wants to get their feet wet. We do have 2 workshops coming up. These are 90-minute interactive sessions, and because of our global customer base, we're going to offer them one time when it's evening in LA and daytime in Asia, and then the other way around we're going to do the next week. So on the 19th of May, that's in a week, it's going to be at the same time. And on the 26th of May, it's going to be a 12-hour time difference so that it is actually morning in LA and evening in Asia, but this will allow some of the European people who don't like to stay up super late to come on. I also told you about New Space Hub. You've got the discount code there. They are really a cool place to poke around if you are interested in the sector. And if you aren't already familiar with these, crunchbase.com and owler.com are really good places to go to find out about a company's investment history and to get a little bit more information on what they do. Spacecapital.com. Actually, they were the ones that provided the financing report I showed you with the graphs. They're a very good resource. They put out reports every single quarter. So if you want to get a little bit better sense of financing there, you can just go and download any of those reports for free. There are a lot of other reports you can look at. The NBC, the trillion-dollar economy that we were talking about, the $3 trillion economy, I did not give you that particular link. Let me actually grab that now for you, see if I can cut and paste it. And 1 second. All right, so I'm going to give you 2 links here, okay? The first one is that report from Morgan Stanley. And then the second one is actually a very nice year in review from space.com. Space.com in general is a good website to be able to look at. And they provide just all kinds of information on what's happening now and what's happened in the past. So here's my call to action to you. Secure your spot now. These prices are in US dollars because we are global. We usually charge $99, but this course is limited to 20 people per session. If you sign up today, this discount code is good until Thursday, the 14th. Get a 30% discount for signing up today. And again, these are the upcoming dates. And we hope that we will actually see you there. So I'm going to close with that. I'll leave this up for a minute here. These are the direct links to the, if you don't go to our website, the direct links to the registration themselves, to the 2 registration pages. And what I'd like to do at this point is to go ahead and open this up to questions. And you should feel free to email me at any point if you want to know more about these workshops or you just want to know about space tech in general. So I'm going to open up my chat window here. Made lots of positive feedback. That's awesome. Somebody was asking about China. So that was David, right? What was your specific question about China? See if he's still on.
I was just, because you commented on all the space startups in the other countries. You didn't comment on China.
Yeah, you can go into New Space Hub and get more information on that. And now part of the thing is the Chinese government isn't very forthcoming, and their work is all just government-based, right? Sometimes you'll find out that something is launching, just before it launches. So we're not really sure exactly what's going on. But if we can talk about this offline, and we can certainly get as much information as is out there.
No, it's okay. I just want to hear your comments. That's all.
Yeah.
Good enough.
Okay, great. So Supriya is asking about governance aspects. So you're talking about regulatory frameworks. Actually, there's a group called the Observer Research Foundation that does a lot of research on this. It is the Wild West. Different countries have their different needs. Different countries have their different requirements. So we've run into issues because of this being a very new sector. There are issues with who owns a payload. And typically when you send a rocket off into space, whoever's built the rocket immediately owns it. So our research kits that we do with the students, we source them in the US, we sent them to Australia, and then they were built and processed in Australia and then sent back to be launched by, I think that year it may have been Northrop Grumman, not SpaceX. And then we had to go through all the documentation and try to figure out who owned it. Because nobody knows, right? I mean, nobody's really had to think about this kind of stuff before. Government interactive discussion group would be good. Yes, Rebecca, thank you. And I think you would be a very good person to lead it, in fact. So she is at RMIT in Melbourne, and she's a legal expert and very interested in space law. So are we littering the Earth? Are we littering space like we littered the Earth? The answer is yes. And there's not a lot up there, but there are thousands and thousands of pieces of junk that are bigger than, I think, a size of, maybe like a few centimeters. If you look at things that are the size of dust, there are well over hundreds of thousands of particles up there, and that matters. The reason that matters is you could have something that's very small that's coming at you at 20,000 kilometers per hour, and it can punch a hole through a solar panel. There are startups out there that are looking at cleaning up. Astroscale, which is located in Singapore, is a good example of this, and there are a number of others. Again, newspacehub.co will tell you. So there are people thinking ahead now. The issue, though, at this point in running a company, a cleanup company, is who's going to want to pay you for it? How are you going to monetize that? It seems like a very good idea, but where will your customers come from? My guess is it would be an insurance company that would probably want to lower their risk by having you clean up the orbital altitude where their particular spacecraft are flying. All right, so the barrier to space, hey Aditya, the barrier to space asteroid mining seems rather high, but is that changing? What's interesting about that is I think people just aren't seeing how valuable it could be. So it costs a lot, but look, we've already done so much of that already. Like we were saying that China's going to go to the moon and return with samples this year. The Japanese have returned with samples already from an asteroid. We go to Mars and we dig around with robots all the time. Somebody has to figure out an effective and affordable way to put that together. And I'll tell you, the first person that goes up there and brings back, you know, a ton of molybdenum is going to do very well, because there's some really expensive and rare metals here on Earth that are just out there, just in abundance. So yeah, I think it'll take a while, but it's something I would really like to see. Okay, so what else here? What about bringing back diseases and bacteria that we have never heard of before? So that actually is a question about, is there life beyond planet Earth? Is there alien life? And if you believe that there is alien life, then, and I kind of do, there's no way that we on this one planet, on this one small star, can be the only life form out there. When people do come back from space, the astronauts are in quarantine for a few weeks specifically for that reason, in case they have any sort of bugs that they brought back that they picked up in space, something that we don't know about. But again, this is where the doctors will have to come in and the biologists will have to come in and tell us what to do. So, okay, so I'm going to send you guys, before I forget here, thank you very much, Jarek. Here is a feedback form that Jarek very kindly has put together for us. So please do feel free to go in and provide feedback, because we want to be able to do this again, and we want to make sure that we do it in a way that completely meets your needs. I'll just take one more question. We're already over by a few minutes, but we did start late. Anybody else have any other questions? All right, so capitalism, Elon Musk. Okay, so do I think Elon Musk's eccentric behavior may or may not impact SpaceX's continued success? So define success. Will they still have really smart people doing really cool stuff and launching into space? Yes. Will it affect his finances, his financing? I don't know. I don't think so. I mean, I think part of the reason that we are so fascinated with him is because he does what he does, and he's capable of continuing to do what he does. I mean, if you look at just even something you might have access to, which is a Tesla, the amount of technology on there, the fact that you can just go and watch Netflix in a car now, you know, using satellites to convey the signal. I mean, he's doing some things that nobody's ever thought of. So yeah, he goes and he does funny things on radio shows and gives his kids names that cannot be pronounced, but I think that they'll keep growing. And okay, so last question, because I think this is a good one. How do we encourage developing countries to invest in space? I think that you have to convince them of what's in it for them. And the economic return in terms of, I think agriculture is a very good place to start with that. Because if you can increase your crop yields by using data from space, then, and you can get somebody to take the data and provide it as a product to the local farmers, you know, they will, you know, that's a good way to get the process started. I think once you see the benefits to it, then you can actually go in and convince people that, yeah, this is worth your time and your money. All right, well, thank you very much, you guys. I really do appreciate your time. Now, go ahead and do sign up for the workshops, because we're only allowing 20 people per session. And I look forward to hearing you about what you guys are thinking in the feedback form, and have a good rest of your day.